Okay, so in 8.3, we looked at how to write a complex number in trig form, and we did two things with it. First thing we did was multiply two numbers in trig form, and we divided two numbers in trig form. We're going to look at two other arithmetic operations today. The first one is raising to a power, and the formula we're going to use to do that is called de Moivre's theorem. And the second one we're going to look at is taking roots. There's no special name for that formula. Right? So we did multiplying and dividing together because they kind of undo each other. And same with raising to a power and taking a root. Those also cancel each other out or undo each other. So for everything we're going to do today, for it to work, we have to use trig form. Okay? Standard form is not going to work for us. All right, so let's say that we had a number in trig form, just very generically. I don't know what the radius is, and I don't know what the angle is. When we do an actual problem in a minute, they will give you a radius, and they'll give you an angle, like that, 2 pi over 8, or they'll fill that part in. Okay, what I want to do is raise that to the second power. And the goal is to see if we can notice a pattern so that if we have to raise it to the third power or the 10th power or the 200th power, we can follow a pattern rather than having to do it out. Because think about if you're raising something to a power, right, like this. Let's take 2 plus 3i, and let's say I wanted to raise that to the third power. Okay, third power is not even that bad. It's still going to take me at least a minute or 2 minutes to do that, right? Because that means to do this. Now just imagine it was to the 300th power. Okay, it's only 3. So 2 plus 3i, 3 times. And now I need to FOIL all that out. So I get 2 times 2 is 4. 2 times 3i, another 2 times 3i, and then 3i times 3i, that's 9i squared. Haven't even done anything with the 2 plus 3i on the end yet. So I'm going to handle the first part. What's I squared?
-1.
And what's -1 times 9?
-9.
So -9. And what's 4? Take away 9.
-5.
So I have -5. What's 6i plus 6i?
12i.
So 12i. Okay, so that's 2 plus 3i squared. Right? I've done that. Now I want 2 plus 3i cubed. So I got to multiply one more time. Okay, so -5 times 2 is -10. -5 times 3i. 12 times 2i, and 12 times 3i. 12i times 3i, that's 36i squared. Okay, so now I got that. Okay, like terms, -15 and +24.
9.
That gives me a 9i. It's that and that. And now I squared is what again?
-1.
So that's -36. What's -10 minus 36?
-1.
Okay. So that's how long it took me to raise that to the third power. Right? If that was to like even the 10th power, to write that out 10 times, it's going to take a long time. So we're going to learn a better way to raise that to the third power. Now, just to confirm that we did it right, let's take 2 plus 3i, raise it to the third power, and see if we get -46 plus 9i. Yeah, so we did it right. It just took a lot of steps. All right, so now let's try something in trig form. Let's take r cosine theta, I sine theta, and multiply it by another r cosine theta, I sine theta. Okay, I'm just raising this to the second power. Okay, so really you have 4 factors you are multiplying together there. 1, 2, 3, and 4. When you multiply, does it matter what order you multiply things in? No. Like 5 times 2, 2 times 5. Order doesn't matter. So let's do the easy ones first. What's r times r?
R squared.
So that's r squared. So now pretend like that r, it's now in front with the other one. And the rest of it, that's a distributive property. What's cosine times cosine? So cosine squared. I have cosine times I sine. And then I have another cosine times I sine. So when I combine those together, how many will I have? 2. I have 2 of the cosine times I sines. So 2 I'm just going to write it like that. 2 of the cosine I sines. So 2 of those. And now the last part. I sine times I sine. Well, what's I times I?
Or I squared.
So that's going to be an I squared. But if we want to fix it right now, we can make it a -1. And what's sine times sine? Sine squared. Okay. So now I want to rearrange that a little bit to make it look like something hopefully you'll recognize. All right, so we've got r squared times, let's put this minus sine squared next to the cosine squared. Cosine squared minus sine squared. That's something special.
Cosine 2 theta.
Yep, so we'll write that in a second. Plus, I'm going to put the I just in front of everything for this middle part. I'm going to put the I in the front of it. And I'm going to write this as 2 sine cosine. So all I did was reorder some things. Cosine squared is still right there. Sine squared with the negative in front is right there. And the 2i cosine sine, 2i cosine sine. All right, so now let's focus on this and then that. What is cosine squared minus sine squared?
Cosine 2 theta.
Right. That turns into cosine 2 theta. And what's 2 times sine times cosine?
Sine 2 theta.
Yeah, that's sine 2 theta. So, when we raise this to the second power, we get that. We get r squared cosine 2 theta plus I sine 2 theta. Now, without actually going through it, I want to see if we recognize the pattern. And anybody think they know what r cubed would be?
R cubed.
Well, I'm sorry, z cubed. Z cubed, yeah. What would z cubed be?
R cubed.
R cubed.
2 cos.
3, that was 4.
Is it the same thing? No, because
Cosine what?
3
You mean cosine 3 theta plus I sine 3 theta. All right. How about, let's do one more. If I asked you to raise that to the 5th power, you'd have to write it out 5 times, but when you did everything out and simplified it, what do you think you would get?
Cosine 5 theta plus I sine.
R to the power 5.
R to the power 5.
Cosine times theta.
5 theta plus I sine theta.
Yep. So instead of raising something to a power and having to do out all of these steps, right, and that was only to the third power, could be a lot worse than a power of 3. We can eliminate all of those steps and turn it into 2 calculations. Take the radius and raise it to the power. Take the angle and multiply it by the power. Doing those 2 steps will take the place of all of that. And that's called Moivre's theorem. So if you want to raise any number in trig form to a power, you do 2 things. Take the radius, raise it to the power. Take the angle and multiply it by the power. So what we'll do is we'll go back and do the 2 plus 3i problem that I did by hand, and cubed it. But I'm going to change it to trig form and try this formula and see if it works. Now for cubing something, could I do it just as fast either way? Maybe. Depends. But if you had to take something and raise it to like the 40th power, could I do that just as fast either way? No. The trig form I could probably do in under 2 minutes. The standard form, it could take me 15, 20 minutes to do it that way. It could be I mean, there's going to be hundreds of steps. It's going to take a while. All right. So again, it all depends on being in trig form. All right. So let's go back to the 2 plus 3i, and let's cube it, but change it to trig form first. What are the 2 things that I need in trig form?
The angle and then the radius.
And the radius. When we square 2, we get how much?
4.
And when you square 3?
9.
Okay. And when we add them up and take the square root, we get the square root of 13. That's my radius. Okay. 2 plus 3i. I'm somewhere in the upper right quadrant. What's the formula to find the angle if you're in quadrant 1?
The inverse tangent of log over x.
Yeah. And I'm going to round this to 3 decimal places because I want to get as accurate of an answer as I can, because I'm going to compare it to what we already got, 46 plus 9, negative 46 plus 9i. If I round, it won't come out exact. Instead of negative 46, it might be like negative 46.0001. Right? But if it comes out that close, then we know the method I'm showing you now works. Okay. So inverse tangent of 3 over 2. 3 over 2. So that's an angle of 56 well, I guess we'll go to 2 decimal places because to the 3rd place it would round to 0. So 56.31. All right. Now, here's our number in trig form. R cosine theta plus I sine theta. And we are going to raise that to the 3rd power. And the hope is we get negative 46 plus 9i. Okay. So instead of having to cube it and do out all these steps that we just did here, I do 2 calculations. How do I get my new radius?
3 times square root of 13, and then 3 times both of
The cube root of 13, square root of 13 times
So say that again. Take the square root of 13 and
cube it.
cube it. That's your new radius.
And then it would be cosine 3 times 56.31 plus I sine 3 times 56.31.
Right, I got to multiply that 56.31 times 3. Gives me 168.9. Well, if we round up, it's 168.93. Okay. That's degrees. degrees. Now, does that look exactly the same as that? No, that's standard form. That's trig form. But if we did everything right, they should be the same answer. What can I do with this to see if I get that?
Distribute.
Distribute. Yep. So take square root of 13 cubed, square root of 13 cubed, and multiply that by the cosine of 168.93. And if I do that out, what number am I hoping I get?
Negative 46.
Negative 46. And we do. Okay. So doing it in trig form, I got the same real part. Now, take that, multiply it by the sine, okay, distribute it out. And what number am I hoping I get this time?
9i, positive 9i.
Well, the I is going to come in when we multiply it after. We're really just multiplying it times the sine.
Oh,
So you can get that.
So we're just going to get 9 or something extremely close to it. 8.99998. Yeah. Okay. So what I'm trying to show you is doing it in trig form and doing it in standard form, you get the same thing. But this is much faster. All right. Any question on that one? All right, let's try this one. 1 plus root 3i cubed. Now, if I wanted to do it in standard form, I would be going through all of these steps right now, all that stuff. What do I have to do to this number first before I can use de Moivre's theorem?
And the radius and then the angle.
Right, we've got to get our radius, we've got to get our angle. We're going to raise the radius to the third power, and we're going to triple the angle that we get, and that's our answer. Okay, so let's find our radius. What do you get when you square 1?
1,
And when you square root 3?
3.
3. If you add those up and take the square root, what's your hypotenuse? Hypotenuse is 2. Okay, so that's my radius. 1 plus root 3, somewhere over there. What's the formula to find my angle in quadrant 1?
Inverse tangent of whatever is the square root 3 over 1, so just square root 3.
Yeah, so it's the inverse tangent of square root 3. And that's going to give us a nice answer of 60 degrees. Okay, so there's your radius and there's your angle. Now, to get the final answer, what are we going to do with our radius?
Cube it.
We're going to cube the radius. And what are we going to do with our angle?
Times it by 3.
We're going to times the angle by 3. Okay, so that's going to give me 8 cosine 180 plus I sine 180. That's all the work to get it to the third power. And most of the work to cube it wasn't even cubing it. It was actually just rewriting the original problem in trig form first. Once we did that, cubing it was extremely easy. Okay, so that is trig form. What if they said to write your final answer in standard form?
You just distribute.
Right, we just distribute that out. So 8 times the cosine of 180 gives me negative 8 plus, now I have to do 8 times the sine of 180. 8 sine 180 gives me 0. So I have I times 0. I times 0, well, that's just 0. So I get a final answer of negative 8. When you write it in standard form, you don't have to put 0i. If you put 0i, I'd still mark it correct. But if it's 0, you could just write negative 8 like that. All right. So that's what you get when you raise 1 plus root 3i to the third power in trig form and standard form. Any question on that one?
How do we get negative 8 plus I times 0?
So we distributed that 8 out to the cosine 180 and then to the sine 180. But you would only do that if they ask for standard form. If they don't, you would stop with the box right here. Okay. Any other question? Anyone feel like they want to do one more of Demoivre's theorem?
Sure.
Okay. So we'll do this one real quick. So raising it to the 8th power. This is one you wouldn't want to attempt in standard form. To the 8th power, it's going to be a lot of steps. Okay. First thing we need is trig form. 2 letters you need in trig form are radius and angle. Yep. Okay. Well, when you square this, the negative is going to go away. So the negative, that doesn't have any effect on finding the radius. When you square this fraction, what do you get?
2 over 4.
You get 2 over 4. How about when you square this fraction?
2 over 4.
2 over 4 again. What's 2/4 plus 2/4? 1. And what's the square root of 1? 1. Okay, so your radius is 1. And your angle, well, negative, positive. Left, up. Somewhere right about there.
180 plus inverse tangent or square root 2 over 1.
So when you divide this by this, what would you get?
1.
Negative 1.
Negative 1.
Negative 1.
These two numbers are
This
opposites.
is a negative.
Yeah.
Okay, so since those two numbers are opposites, when you divide them, you'll get negative 1. And I just have memorized the inverse tangent of negative 1 is negative 45. Okay, so if you take 180 minus 45, that gives you an angle of 135.
Do you not want us using negatives? Like, should we always add the 180? Or even if it's like.
Should you always add the 180?
In the test, if we get negative answers, even for ones that aren't set up like this, would you get a positive answer? So,
Oh, for the angle itself?
yeah.
I would say, yeah, a lot of times they will add 360 to make it positive, but we don't need to in this one.
Yeah.
Okay, the only reason I added 180 was not to make this number positive.
No, it is because of the.
I added 180 because I have to. That's the rule for the formula in quadrant 2. Yeah. So I think we talked a little about that yesterday too. Okay, so now, how am I going to get my radius for my final answer?
1 to the power. Yeah, it's 1.
So it's 1 to the power of 8, which is just 1. And then cosine, how am I going to get my angle?
135 times 8.
Right, I'm going to do my angle times 8. So that gives me an angle of 1,080. Okay, that's a big angle. We've got the same issue here as if we had a negative angle. It's not between 0 and 360. So what would we do?
Subtract 360.
Yep. And this is something you would want to do. Subtract 360 as many times as you need to until you get an answer between 0 and 360. Okay, so it's cosine 0, I sine 0 degrees. That is what you get if you raise this to the 8th power. And if they wanted that in standard form, you could multiply it out. Cosine of 0 is 1 plus, and then the sine of 0, sine of 0 is 0. Since the sine of 0 is 0, that wipes out the imaginary part. And the final answer is just 1. So raising this to the 8th power, you get 1.
Could you leave it at 360 instead of 0 degrees?
So if it was a multiple choice question, I probably would not give that as a choice. So you'd have to know it's the same as that. If it was a short answer question, I would probably say write your angle between 0 and 360.
Oh, so it can't be 360.
It cannot be
Okay.
360. I would specifically say like your angle has to be greater than or equal to 0 or less than 360.
Okay.
So yeah, if you left it as 360 and it said that, you'd probably lose a point. Okay. So any questions on trig form? Standard form? Yep.
Why do you square the function before putting the radius? I don't understand why you do that.
Why do I square this?
Yeah, both?
Oh, I'm doing Pythagorean theorem.
Oh, okay.
Yeah. So I'm squaring each side, adding them up, and taking the square root. Yeah. Okay, so now let's go back to example 1. In example 1, to get this, we cubed that. How would I undo cubing something?
Take the cube root.
I would take the cube root. So if I took the cube root of that, I should get what?
1 plus square root 3i.
I should get that. So the question is, how do we do that? How do you take the cube root of -8 and get that answer back? Well, calculator is not going to help, because if you type in math and you go to cube root, there's another number that's also the cube root of -8, -2. The calculator is not going to give you the imaginary answer. Okay? That's the imaginary answer when you cube root -8. That's the real answer, -2. So we want all the answers. So how do we get the one that the calculator gives us and this one? Right. And there's actually one more. So I have to show you how we do that. So the first thing to understand about roots is there's always as many answers as that exponent right there. So if you are doing a cube root, I'd be looking for 3 answers. If you're doing a 5th root, I'd be looking for 5. Right? I would say on the test, we probably won't do anything more than a 4th root. The higher the root, the longer it takes to do, because you have to find that many answers. All right, so we just talked about that. How would we undo cubing a number? We would use the cube root. And if we took the cube root of -8, which is what I had circled in green at the bottom, 1 plus root 3i would be one of the answers. One of the answers, not all of the answers. All right, so I think the steps are kind of confusing if I write them out without an example. So I'm going to do an example, and I'll write kind of some notes in the example as we go through it. Okay. So the first thing to understand is what kind of equation do we need to set up? So let's try something without complex numbers and see if we can figure it out. Let's say that I was trying to explain to somebody how to find the square root of a number. Right? And they said, I don't know what square root means. Can you show me what that means? I'd say, okay, so square root means that you are looking for a number times itself that gives you whatever you're trying to take the square root of. So if you were trying to take the square root of 16, this is the equation I would tell you to set up. Something times itself would give you 16. If you were trying to find a cube root and you didn't understand what that meant, I'd say, okay, cube root means, if you want to find like the cube root of 8, I would say you can take some number, raise it to the 3rd power, and get 8 as the answer. If you can figure out what number to fill in for z, that number that you fill in is called the cube root. Right? That's how I would explain it. So that's the kind of equation we're going to set up each time. something to a power is going to equal something else. So that's what we need to figure out. We need to figure out how to satisfy that equation. Satisfy means how do we solve it? This is going to be the root, square root, cube root, fourth root. So you're going to know this number. You're also going to know this number. That's what you're taking the root of. Square root of 6. Okay, we put a 6 right there. Cube root of 28. We put a 28 right there. So this is what you are taking the root of. The trick with that, though, is it's going to have to be in trig form. Okay? To make this work, we have to do everything in trig form. Okay? And this is what you don't know. So that's the unknown. And because we're doing everything in trig form, the unknown is going to have two parts to it. It's going to have a radius, and it's going to have an angle. That's how we're going to solve it. So let's try this one. In this problem, they want us to find, we're not going to graph. We're going to find the fourth roots of 1. So what times itself 4 times gives you 1. For some reason, our book, they use a special word when they're talking about 1. You might see the word unity. So if it confuses you, just think in your head, unity means 1. If it's roots of any other number, they just say the number. Like find the fourth roots of 3. They would just write 3. Right? But finding the fourth roots of 1, they use the word unity to represent 1. Okay, so this is the first thing you'd set up. This is your equation. So z is your unknown. 4 is the root that you're taking. We're doing fourth. And a is what are you taking the root of? We are finding the roots of that number right there. So that's the very first thing you have to set up. Now, without even solving that, I think we know 2 numbers you could multiply by itself 4 times to get 1. What's something times itself 4 times that gives you 1? 1. 1 times 1 times 1 times 1. So 1 is an answer to this problem. And what other number times itself 4 times? Negative 1. But there are 2 more, right? Because this is a fourth root. So there are 4 answers to this problem. So we'll go through it. We're going to get these 2 again, even though we already know them. We'll get those. But we're also going to get those. All right, so the first thing we have to do is write in trig form, both the left-hand side and the right-hand side. The left-hand side is easy. Z is unknown. Okay, we don't know what z is. So all we're going to do to z is instead of representing it as a letter like that, we're going to represent z in trig form. Just like that. We're literally just going to change the letter z to r cosine theta plus I sine theta. That's the same step in every problem. So change z to that. So left-hand side, let z equal r cosine theta, I sine theta. Now, I didn't say anything about the power of 4. The power of 4 stays right where it is. You're just going to change what's in the box right there to what I wrote right above that underline. Okay, so now the right-hand side, that's something very specific. We know it's the number 1, so we have to change that to trig form. Find radius and theta. as exact numbers. So let's think about the number 1. There's no imaginary part. So what could we put on the end?
I0.
Yeah, you could put a 0i. You don't have to, but I'm just saying if you want to. It does not have an... oh,
Not broken.
that was supposed to be hidden.
Oh no.
Hide that again. So, we have to find what that is in trig form. 1 plus 0i. Which way do I go to graph the point 1 plus 0i?
Up. To the right.
To the right.
Right one.
So remember, we go right 1. If you go right 1, what's your radius? 1. And what, you don't really even need Pythagorean theorem, you can just count 1. And what's your angle? 0. That's what we're going to change the right-hand side to. Right? Write the right-hand side in trig form. Use that as your radius. Use that as your angle. Okay. So let's rewrite it. So we've got r cosine theta, I sine theta. That's what's in the box. And that's all being raised to what power? 4th power. And now on the right-hand side, we're going to write what's in that box in trig form. So it's r cosine 0 plus I sine 0. All right. So now there's nothing we can do on the right, but we can do something on the left. So simplify the left-hand side. If we do the left-hand side to the 4th power, what would my radius be? R to the 4th. And what would my angle be if I do this to the 4th power?
Theta times 4.
Theta times 4, which we're going to write as 4 theta. So that's all we do with that step. Honestly, I usually just do that step as I write down the original problem. So it's less writing, but I'm trying to show every step. Okay, so we simplify that, we do that, we do that, and we do that. Okay, so everything highlighted in yellow, that's explaining what we're doing. All right, so now, how many letters do we have to solve for on the left side?
3.
2. Right? There's an R on the left side, there's a theta on the left side. Once we know those two things, we will have the answer to our problem. What is the radius on the left-hand side? The radius on the right-hand side is a 1. R to the 4th. Yep. So now we're going to set up 2 equations. We're going to say radius on left equals radius on right. So that'll be the first one. And what's my angle on the left?
Theta. 4 theta.
4 theta. So angle on left is going to equal angle on the right. So those are going to be the 2 equations we set up that are going to give us our answers. Okay, so tell me one more time, what was the radius on the left?
R to the 4th.
R to the 4th. And what was the radius on the right?
1.
1. Okay, we'll come back and solve that in a second. What's the angle on the left?
For theta,
4 theta. And what's the angle on the right?
0 degrees.
0 degrees. Okay, I'm going to come back to that in a second. All right. How do you get rid of an exponent of 4?
Take the fourth root.
Take the fourth root. And now we're looking, r is a distance, so it has to be a positive number. What number times itself 4 times gives you 1, and it's a positive number. 1. So when we write our final answer, the radius is going to be 1. Okay. Now, let's look at our angle. We have angle on the left equals angle on the right. And if we solve that, we will get one answer. But we want all the answers. Okay. How many answers did I say this problem is going to have? 4. Does anyone remember, what do we put on the end of something so it gives us all solutions? We put plus a number times n.
260 or 2 pi.
Yep, plus 360 or 2 pi n. Okay, we've done that before when we used the graphing calculator to solve for all solutions. If you forget the plus 360n, you will still get one answer. But that's all you will get, one answer. All right, so now we want to solve for theta. How are we going to get rid of that 4 in front? Okay, so we're going to divide, divide, and divide. 0 divided by 4 gives me what? So I really don't even need that then. Okay, that part goes away. 360 divided by 4 gives me 90 n. So now there's going to be, how many answers again? 4. So you're going to let n equal 4 different values. 0, 1, 2, and 3. Oh, your phone? Yeah. So you're going to let n equal 4 values. That's how you get the 4 answers. 0, 1, 2, 3. If I wanted to get 5 answers, I would let n equal 0, 1, 2, 3, 4. So this number ends up really being 1 less than the number of answers you want. Okay. If you want 10 answers, you'd go 0 through 9, and that would give you 10. Okay. So that's all the hard stuff. Now we just have to write all the answers. Okay. The answers are all going to be on a circle. How big of a circle are they going to be on?
Radius of 1.
They're all going to be on a circle with a radius of 1. So you're going to get an answer like here, 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 and over here. Every answer is on the same circle. So they all have a radius of 1. So let's write that down 4 times. So we're going to have r cosine. I'm going to come back and fill in my angles in a little bit. They're all going to look something like that. And then we're going to have n equals 1. And then we'll have it again for n equals 2. Paste it again. Space these out. Okay, so I got n equals 0, n equals 1, n equals 2, n equals 3. Okay, so now what we do is fill in each one of these numbers into that formula and write down the answer you get. Let's start with 0. What's 90 times 0?
0.
0. There's your first one. Next number you fill in is 1. What's 90 times 1? 90. 90. 90. Next number you fill in is 2. What's 90 times 2? 180. And the last one, 90 times 3?
270.
270. those are your 4 answers. Guys, it takes a couple to go through to get used to doing it, but the steps are exactly the same every single time. So you write your initial equation, put it in trig form, you simplify with de Moivre's theorem, and then you set up your 2 equations, and then you write your final answers. Okay, any questions how we got the 4 answers we got right there? Yeah.
Not on that, but do you want us to simplify those?
If they asked you for standard form, then yeah, I could distribute that out and get my
Yeah,
answers.
'cause that's one we could do.
So remember, we said 2 answers to this problem before we even started it were 1 and -1. Well, if you do the top one out, cosine of 0 gives you 1, and the sine of 0 gives you 0. Because this part is 0, it basically disappears. And you're left with 1 times 1, which is how much?
1.
1. There's the first answer of 1. Okay. There's another one that would come out to -1. And the other 2 that we didn't get originally would be imaginary. This one is imaginary, and so is this one. Okay, but for now, I don't want to simplify those any further. Okay, let's try another one. Right, let's try the cube roots of -8. So this one only is going to have how many answers?
3.
Just 3, not 4. Okay, what's the initial equation I would set up? This is like if you were trying to explain to somebody what it means to take a cube root.
Z cubed equals -8.
Right, it means that there is some number you can raise to the third, some number you can raise to the 3rd power and get -8. Now, what are we going to change z to?
Cubed cosine theta plus I sine 3 theta.
Yep, so we can do both steps at once. We can change it to trig form and use de Moivre's theorem. So the left side becomes r cubed and the angle 3 theta. Okay, now -8. Where is that when I graph it?
Directly to the left.
To the left, how many units?
8.
8. That's to the left 8 units. What's my radius if I go left 8 units?
8.
-8.
Remember, radius is always a positive number, so radius is 8. And what's my angle if I'm over there? 180. Yep. So that's your radius, and that's your angle. So 8 cosine 180, I sine 180. Okay, now set up your 2 equations. What's going to be the equation I write down for the radius?
R cubed equals 8.
Yep, radius on the left equals radius on the right. We'll come back to that. What's going to be the equation I write down for my angle?
Theta equals 180.
3 theta.
380.
Angle on the left equals angle on the right. And if you solve that, you will get one answer. So to get all of them,
Plus 360 then.
right, we always put a plus 360 in on the end. Now we solve it, and those are our answers. Okay. How do we get rid of raising to the 3rd power?
Take the cube root.
Take the cube root. What's the cube root of 8? And I'm looking for a number that is real, because it's a distance, and positive.
2.
2. Yep. So that is going to be the radius on every answer I write down. Okay. Now I need a formula for theta. I have a formula for 3 theta. How do I get just theta? Divide by 3. Remember, here, there, and there. So what does theta equal?
60 plus 120n.
60 plus 120n. Okay. How many answers are we going to get for this problem? 3. So we're going to plug in 3 numbers for n. What numbers?
0, 1, 2.
0, 1, 2. And now just write your answers. Okay. What's my radius for each answer?
2.
2. First one. Second one. And my third one. Now we just fill them in. All right, let's start with 0. What's 120 times 0? 0 plus 60.
60.
There's your first answer. Okay. What's 120 times 1?
120.
Plus 60.
180.
That's your second answer. And the last one, 120 times 2
240.
plus 60.
300.
300. That's it. Those are your 3 answers, plugging in 0, 1, and 2. Okay. Any questions on how we got those 3 answers? All right. So that's raising to powers, which I think is a little bit easier, and then taking roots. It's not really that hard, it just takes a little bit longer. There's more steps. I had another example, but if we want to practice one from the homework tomorrow, we can do that one. If we did that one, how many answers would there be? There would be 5. Yeah. So that is the homework. Let me double check. Okay. So we got 3 through 5, that's actually a review from yesterday. So that's review. 8 through 12, that's all the Moivre's theorem.
12 questions.
Is that the same as yesterday?
This year was 16.
I'm just going to change this to. On 27 and 28, they mentioned something about graphing. Don't graph. You don't have to do what they mentioned about graphing in those 2 questions. And then 35, that's all. Okay, so I took off the questions, just make sure you caught that. Okay, so we'll go over that tomorrow, and then we'll look at the beginning of 9.3.